Hello, everyone, and welcome to Superscale Your Games Backend with AWS Database Services. My name is Michael Labib. I'm a Principal Solutions Architect here at AWS. I'm going to be focused with you on some of our database services, and the time that we have today, I'm going to kind of give you a primer and an overview of various different services that we have today. And so if you think about a data platform, we have a variety of things that cover all sorts of types of data use cases and different types of databases that you might need within your games, right? So everything from a relational game to a relational database to non-relational databases to analytics. If you need to build a data lake with Amazon S3, we have a variety of things that we can offer you from a managed services standpoint. And that's essentially, what we're going to be talking about today. I am going to be picking out a few things, due to the duration of this meeting. But if you have any questions afterward, please feel free and stop by the booth and ask me questions afterward. So the first thing, I'd like to talk about is, the different types of workloads you can run on AWS Database Services. So what it first boils down to is, what is that use case? And we have customers, especially gaming customers, who come with a variety of different types of use cases that they want to use AWS Database Services with. And that's everything from platform services to analytics to just storing game states or caching your data or leaderboards, all sorts of types of things that you can do. And we have services that can support those use cases. But before we even get to that point, the first conversation that I like to have with customers is really understanding, how exactly do they need to use that data, right? How exactly does that query need to look like? What type of data are we talking about? Is that data connected data? Is it highly relational data? Is there any type of dependencies on this data? What type of volume are we talking about? What's your latency and your all the sort of requirements that you might have, and that really feeds into what type of database makes best sense for that individual use case. We're no longer sort of thinking about have a one-stop shop database for everything, right? We've kind of surpassed that point in time, and the right way to kind of think about this is having a specific database, an optimal database for that particular workload. And so let's start with Amazon RDS. So RDS essentially is a managed relational database service that we offer you. We have 6 different engines that you can choose from. And essentially what we do is we remove all the administrative tasks associated to managing that, including patching, managing failovers, the deployment topologies. We'll make sure that when you deploy that RDS database, it's in an AZ environment. It's multi-AZ, failovers, and it's and it also has the ability to scale very easily. And so that's the general value with moving to a relational database is we remove all the heavy lifting associated to managing this, allowing you to really focus on your game and building your game. For the sake of time, we'll kind of pick one of these engines, which is Amazon Aurora. So Amazon Aurora, I like to think of as kind of like a V2, right? It's like the next gen relational database built for the cloud. And really it has incredible speed, highly available with 6 copies of your data, 2 copies in each AZ. And it's a drop-in replacement for both MySQL and Postgres. And it's in terms of simplicity and cost effectiveness, it's incredibly cost effective. We do a lot of point-in-time recovery for you. And then there's additional capabilities that really make it very useful when building a game. So for example, you can have up to 15 read replicas. Those read replicas can auto-scale. So say, for example, you have an incredibly high read workload. A lot of people are reading game data. You can scale that very easily and dynamically with Amazon Aurora. In addition, we have pretty large thread pooling and connection pools that you can establish with Aurora. Your volumes can grow up to 64 terabytes. And when you provision an Aurora database, you don't have to decide, how much storage you actually need. It's going to grow with your data needs. It's also secure. It's fast. In addition, we also offered a serverless model. So say, for example, you're not exactly sure, what type of compute that you're going to need. You can certainly grow and change dynamically that topology using Amazon Aurora Serverless, which is a new feature that's going to be coming out soon. So, for this portion of the talk, we're going to talk a little bit about Amazon ElastiCache and how it can specifically solve specific workloads, whether it be leaderboards, caching, and chat. So the first one, kind of highlighted in yellow there, would be game chat. So we have a lot of, game developers who maybe have a chat application built into that game. Maybe it's part of a campaign where they want to have individual players sort of chatting with each other. A lot of these chat applications can easily be built using Amazon ElastiCache for Redis. And the value here is that Redis offers a pub/sub a model which allows you to publish information to a set of consumers, right? So you can publish this by creating a channel. That channel can have various consuming applications, which could be other players who are reading the dialogue that's happening in that game. Now, the reason why it's kind of off to the side here is it would make a lot of sense to have this as an individual cluster, just managing your chat applications. So it's not sort of disrupting any other operation that you have as your Redis kind of topology. With that said, we also have a lot of customers who are building leaderboards using Amazon ElastiCache for Redis. Redis has a sorted set that makes a lot of sense for building a leaderboard. This allows you to rank data in both ascending and reverse order. Also, querying that data in a variety of different ways and getting that information in sub-millisecond performance. So Redis makes a whole lot of sense for building leaderboards. And when organizations really want to have maybe a stronger durability associated to that leaderboard, some people might even choose DynamoDB for a leaderboard as well. Another use case here would be for caching, and that's kind of obvious, right? You'd always want to place an in-memory database in front of any type of other, relational databases or other kind of data stores that you might have. And this is really going to give you a few benefits. Number one, it's going to speed up your application, so it's going to lower the latency for data retrieval. The second thing that it's going to do is going to increase the throughput associated to the requests. So when you're dealing with an in-memory system, a data store like Redis, you can support millions of operations per second at sub-millisecond performance. So it makes a lot of sense when you're sort of scaling a game. As we're kind of talking about caching, another common architecture would be sort of aggregating different data that you would get from different data sources into a sort of aggregate cache view. And what does this actually mean, right? So, imagine you have maybe some player data in DynamoDB, Amazon DynamoDB. And you also have maybe player purchases that is in a relational database like Amazon RDS. And maybe you also have some metadata that you're storing in S3. What you could very easily do is, kind of aggregate the related data into a Redis sorted set or a Redis hash map, and then retrieve that information directly from Redis and have that single point of reference for all that for that data. Now that's going to eliminate the need of having to execute a variety of different queries. So this sort of speed up your entire workflow. As we're kind of talking about caching, so like in a typical use case, you'd have a couple app servers sitting in front of your relational database or whatever type of database you have. And if you ever run into heavy load, right, say all of a sudden your game goes viral and you're expecting increasingly heavy load, one thing that you could do with Amazon ElastiCache is you can certainly scale that cluster with zero downtime. So some of the ways that you can do that is, say you have a a CloudWatch metric that is, capturing some metrics in terms of, how many requests that how many requests per second, or maybe you're also capturing gets or sets, or memory utilization or CPU utilization. Based on whatever alarm you set, through a Lambda function, you can execute a resharding operation, which is going to let you scale your cache. Now, the value here is you're going to absorb all that pressure that would normally go to your backend database within that cache layer, right? So that makes that cache layer very dynamic in terms of responding to your application. So let's talk a little bit about DynamoDB. So DynamoDB is an incredibly highly available and durable NoSQL database that offered by Amazon AWS. And essentially what you're guaranteed with DynamoDB is a single latency performance, so single millisecond performance. So no matter how large your database is, or no matter how large your volume of storage is in Dynamo, you're always guaranteed that high level of performance. The other thing that you have is you really essentially never need to worry about how much data you need. You never need to worry about the scale and how this thing is going to operate. In fact, you never even see servers with Amazon DynamoDB. So all you really need to do is really focus on that table creation and reading and writing data into Dynamo, and obviously architecting how that table is going to make sense with respect to your usage patterns. And what also Dynamo offers is global tables. This is a fairly recent release where it makes building a global game very easy to do with DynamoDB. So in other words, imagine you have maybe player data that's stored in a table. You can have this data kind of replicated across various regions in a very a multi-region environment, right? So you no longer have to have a database for each individual region. You can have a kind of a one global database for all of those workloads. Other kind of use cases that we see is kind of a serverless model where people are building serverless workloads using DynamoDB. So say, for example, you're exposing operations to DynamoDB via, say, API gateway. Maybe as the requests are coming in, game events are coming in, you're doing some sort of logic in AWS Lambda, which is a serverless function that will trigger based on this Lambda integration that you'd have with API gateway. And then that might be like, hey, I'm seeing this individual event. Maybe it's related to the game. You can persist that game into Dynamo. And then that entire stack there is serverless. There's nothing that you need to worry about in terms of managing the HA or the scale. All that sort of stuff is managed for you by Amazon. And then what we see people do is, like, let's say they have other types of operations. So maybe Dynamo serving as that primary database. They might want to still pull data out of Dynamo using AWS Lambda and DynamoDB streams. And then once they do that, they can drop that data into either their big data lake, Amazon S3, or Elasticsearch if they want to do some kind of searching on top of that data, or again another maybe DynamoDB database for some other type of workload. And so the takeaway here is that with AWS you can really architect based on your needs a variety of different solutions that kind of satisfy every aspect of that entire workload and that flow of data. So Amazon Neptune. So Amazon Neptune is a graph database. We support both Sparkle and Gremlin protocols. And this is, again, fully managed service for you. It's actually in preview state right now. By default, you'd have 6 replicas of your data, two copies in each AZ. And it's incredibly powerful and, and fast. And so when would you use like a graph database? So say, for example, you're storing relationships in your data, or you want to traverse different kind of player information, or you want to recommend activity based on similar players, you can certainly do that by having that social sort of network that you can traverse within a graph database. There's also a number of other use cases, obviously recommendation engines, fraud detection, all sorts of things. And so the value here is really persisting those relationships in a data store that's intended for graph type of queries. And as I mentioned earlier, we support the Gremlin, Apache Tinkerpop, and semantic web with RDF and Sparkle open source protocols. So that's sort of a high level for the purpose of this talk, kind of a primer introduction of the database services. We're actually at booth 21 if you have any questions, and I can happy to take any questions right now if anybody has any questions on any of these services. Thank you.